Welcome, students. In this lesson, we will explore how Newton's law of motion are applied to real world problems. We already know that Newton's law explains how forces affect motion. Now, we will learn how to use them to analyze different physical situations. Let's begin our journey into the application of Newton's law. Learning outcome. At the end of this lesson, you will be able to solve problems related to the application of Newton's law of motion. You will learn to identify forces acting on objects, draw free body diagrams, and apply the equations of motion to determine unknowns such as tension, acceleration, and frictional forces. Newton's law can be applied in many physical systems. In this topic, we will focus on four main situations. First, when both objects are on a horizontal surface. Second, when two objects are connected by a pulley. Third, when one object is on a horizontal surface and another one is hanging through a pulley. And finally, when the object is on an inclined plane. Each case will help you understand how forces interact differently depending on the situation. To solve any Newton's law problems, always follow these five systematic steps. First step, identify the direction and draw free body diagram. Step 2, calculate friction force. Step 3, create two equations based on Newton's second law, F is equal to ma. Step 4, find the acceleration a. And step 5, find tension force T. Let's start with the simplest case, both objects on a horizontal surface. Two blocks connected by a rope are being pulled by a horizontal force Fa. Given that Fa is 60 Newton, mass 1 is 12 kg and M2, which is mass 2, is 18 kg, and that mu k is zero point 0.1. Find the tension in the rope between them and the acceleration of the system. First, identify the motion of the object. Obviously, it will go to the right side, and after that, draw free body diagram. So in this case, we have normal force, tension force, friction force, and weight. Step 2, calculate friction force using formula F is equal to mu times with normal force. And the normal force is actually equal to weight, which is mass multiplied with gravity. Since we have two objects with different weight, so we have to calculate two friction force. Then we start forming equations using Newton's second law. F is equal to ma. F is considered as a net force. If your object moves to the right, it means that forces at the right side minus or subtract with the forces at the left side equals to mass multiplied with acceleration. Then try to make T1 as our subject matter. Next, create equation for second object using F is equal to ma, where F is the net force acting on the object. The net force is determined by taking the force to the right minus the force to the left based on the direction of motion. Finally, we arrange the equation and make the tension as a subject matter before solving the simultaneous equations. Once the acceleration is known, we substitute the value of acceleration into either equation to calculate the tension in the rope. Notice that the tension on both sides of rope is equal. Now we move to the second case, pull by pulley. Two masses hang on a pulley system. One mass is heavier than the other, so the heavier mass moves downward while the lighter mass moves upward. We need to find the acceleration and the tension in the rope. Next step is we write two equations using F is equal to ma1 for each mass. In this question, we skip the step of calculating friction force because there is no friction involved. After solving the equation simultaneously, we obtain the acceleration of the system. Finally, we substitute the acceleration value to find the tension in the rope. Next, let us study a combined case, horizontal surface and pulley. One block is on a table and the other is hanging. First, identify the direction of motion and draw the free body diagram for both objects. Now, calculate the friction force acting on the block on the table. Then, apply F is equal to ma for both objects to form two equations based on their free body diagram. Solve the equations simultaneously to find the acceleration of the system. After that, substitute the acceleration value into one equation to determine the tension in the core. Finally, we consider the inclined plane case. Two blocks are connected by a rope, with one block on a slope and the other hanging vertically. We are required to draw the free body diagram, calculate the acceleration, and determine the tension force. The weight of the block on the inclined plane is resolved into two components, parallel and perpendicular to the slope. Apply F equals to ma along the direction of motion for both blocks. Solve the equations to obtain the acceleration of the system. Then substitute the acceleration value to calculate the tension in the rope. Both methods shown give the same tension value, confirming the correct solution. As we conclude this lesson on the application of Newton's law of motion, we have seen how Newton's principle allow us to systematically analyze forces and predict motion. From objects moving on horizontal surfaces to pulley systems and even motion along inclined planes, we apply Newton's second law to calculate the acceleration, tension, and net force in different physical situations. Thank you for your attention and active participation. Keep practicing because in physics, understanding grows stronger with application. Thank you.